In this episode of Derp Star, I refactored the shark laser beams to use recursion so they can bounce off as many times as needed. I added the energy shields just for example so you can see the effect, but I'll be removing them in the release. Following the rule of 3, since I already have the player beam and space worm beam, I made a generic base class for the laser, which I can extend and add more features to later. First, I'll load the Oceanus dimension in the main class. Then I'll remove the regular shark and naval mine from the default biome and reduce the bumper maximum count. So now only the laser sharks are spawning. The beam deals damage to the player and can be deflected to damage the enemies instead. So now I'll make the generic laser beam weapon, start with a 2D scene and rename it. Then I'll add a line 2D as a child and add a couple points. The first one is at 0, 0, and the second should be snapped to the horizontal axis, like so. Now I'll save the scene and attach a new script and set the class name to laser beam. So now I can open up the laser mount scene and delete the line and beam area nodes. Then I'll drag the new laser beam weapon as a child instead and realign it with the beam emitter. Then I can right-click to toggle editable children, set the fill texture to a gradient 2D, and make a new gradient. Set the middle color to red. And fade to transparent on the edges. Then I'll set the texture mode to stretch to display it and drag the corner down to the bottom so the gradient is horizontal. Then I'll increase the width and set the end cap to rounded. And increase the length as well. Also set the default color to white so the true color is displayed. And I'll remove all the functions from the script for now. So now the sharks still have the laser beams, but they don't do damage or get deflected at this point. Now in the laser beam base class, I'll define the onReady variable length equals line 2D points at 1.x and onReady variable height equals line 2D dot width. Then I'll make the deactivate function set points to an empty array and assign line2D points to the points variable. Then I'll duplicate that. And for the activate function, I'll append zero, 0 as the first point and length 0 as the second point. And on ready, call the deactivate function. And I'll add the activate and deactivate functions to the laser mount class as well to call the corresponding functions. Now in the shark base class, I'll set the aggro range equal to 700 and the isAggro boolean equal to false. Also declare the aggro on and aggro off signals. In the aggro on function, I'll check if not is aggro, then set is aggro equal to true and emit the aggro on signal. And for aggro off, we'll do the opposite. So if is aggro equals false and emit the aggro off signal. And in the physics process, if distance is less than aggro range, call aggro on, else aggro off. Now in the laser shark scene, I'll connect the bumper aggro on signal to the laser mount activate function and the aggro off signal to the laser mount deactivate function. And when I play the scene, you can see the sharks don't activate their lasers until they're within range of the player and deactivate when they get far enough away. Next, I'll make a new scene with an area 2D as the root node. I'll rename it to beam area and add a collision shape as the child. Set the shape to a rectangle 2D. Then I'll save this in the weapons folder and attach a new script. Define the length and height as float variables. And in the set height function, I'll take a float as the parameter, set height equal to h, then set the collision shape extents dot y to height over 2, And in set length, take a float parameter, set length equal to L, and set the x extent to length over 2, and the x position to length over 2 as well. Then in the laser beam base class, I'll preload the area scene, and you can drag the file name up from the browser. Now in Activate, I'll make a new variable for the area scene instance, set the beam area height to height, and the length as well. Then add it as a child to the laser beam node. Now you can enable visible collision shapes under debug, and as you can see, the laser beam area lines up with the line, but when you get too far away, the area is still there. So to fix this and deactivate now, I need to remove child beam area, and if I run it again, the area disappears once you get out of range. Then in the beam area, I'll add a position 2D and rename it max length. In the script, I'll add a variable and make the setter function so I'll set the variable, then set the node position.x equal max length, and this will be relative to the beam area. And I'll add functions to get the raycast start and endpoints. It'll start at the beam area global position and get raycast end. We'll get the max length global position. Now to do the raycasting, I'll get the direct space from the get worlds 2D direct space state, and in the cast beam function, I'll get the raycast start point and end point. The result is direct space dot intersect ray from the start to the end with no exclusions on collision layer 4, which is the third layer in the mask. If there is a result, set length to start dot distance to result position. Otherwise, set length to the maximum length. Now in the laser beam class, I'll change set length to set maximum length in the activate function. Then in physics process, call the beam area dot cast beam. Then in deactivate, I'll set the physics process to false to stop this function from running. And in activate, I'll set physics process to true. And I'll make a draw beam function set the second point to the beam area dot length and call draw beam in the physics process function. So the direct space state variable needs to be on ready, and I forgot the return keyword in the get raycast endpoints. But now, when you get in range, the lasers are activated and you can block them with your shield. So you may notice that the laser beam line and the collision shapes aren't always lining up. That's because the beam area collision shape needs to be local to scene. So now they all have their own unique collision shape, and it matches up with the line that's drawn. Then in the beam area class, I'll make a variable for the area seen equals beam area. And if there is a result from the raycast, check if it does not already have a beam area node. Then we'll recursively add the area as a child of the previous. So I'll make a new area equals area scene dot instance, set the area height to the current height, and add the new area as a child of the current one. Then I'll set the beam area maximum length to max length minus length, and the beam area global position to the result position. Then get the incoming direction, which equals the result position minus the start, and set the beam area global rotation equal to the incoming direction dot bounce on the result normal and convert it to an angle. And finally, I'll call cast beam on the nested beam area. And if there is no result from the raycast, call remove child beam area, which will remove the node if it exists or do nothing if it doesn't. And now you can see the beam areas are deflected off of the player's shield, but the laser beams aren't drawn properly for the second part of the laser. So in the laser beam base script, I'll get the current beam, which equals beam area, and set done to false. And while not done, I'll append the current beam raycast starting position, then set next beam equal to current beam get node beam area. If next beam exists, set current beam equal to next beam. So this will let you iterate over the entire list of beams. Otherwise, set done to false or true. Then at the end, I'll append the current beam, which will be the last one, get raycast end. Now you can see that the laser beam angles are correct, but the position is off. So I'll make the points a vector 2 pool array. And at the end, set points to line 2D get global transform dot transform inverse on the points array, which will make it relative to the line 2D. Also, I can change the joint mode to bevel, which looks a little better. So now the lasers are lined up with their collision shapes and deflect off the player shield. Now I want the laser beam to deal damage, so in the script I'll add a variable for the faction and an export variable for the DPS. Then in the laser mount scene, I can set the DPS through the editor. I'll make it 50 just for testing. And in the laser mount script, on ready, set the laser beam faction equal to the parent faction, which will be the shark bumper. So now in the laser beam, when I make a new beam area, I'll set the faction and DPS and then in the beam area I'll add these variables to the class. Now when I make a new beam in cast beam, I'll set the DPS to the current DPS, and if the beam collides with a shield, set the new beam area faction equal the collider result faction. Now in the physics process, I'll get overlapping bodies and use the connector to deal damage from the beam to the body for DPS times delta amount. So now you can see the laser beams deal damage to the player, and when you deflect them, it does damage to the shark instead. So the cool thing about using recursion is the beam can bounce as many times as needed, and you're not just limited to 2 segments. So to demonstrate this, I'll drag the energy shield from the player onto the laser shark, and this works because the shield collision layer is set to 3, which is a bit value of 4. So in the script, I'll set the faction equal to the get parent faction instead, and in the laser shark on ready, I'll enable the energy shield. So now the laser shark beams are reflected between the player and the shark shields. That's all for this episode of Derp Star. Thank you for watching and have a great day.